So now let's try to find the cosine sine of the most important angles. So of course the most important angles, let's say if you put in this table here, let's say here is the angle A, here is the cos, and here is the sine. So, and excuse me, the most important angles, they are of course, I mean, we can put it in radians or in degrees. Let's put it in degrees. So you have the 0 degrees, then you have the 30 degrees, then you have the 45 degrees, then you have the 60, and of course finally you have the 90. So let's go and find without knowing anything and without having to remember anything, and of course without using your calculator, because in some problems you cannot use your calculator. So let's start. So you see here that I mean the angle 0, okay, since we start measuring from this axis here, I mean, as we said, this was the angle A, so that means you go like this. So for angle 0, which is exactly here, you have that the cos of 0 is what? The cos of 0, I mean, how we said we find it, you bring the projection of this point into the cosine. So here the projection, if you bring the projection of this point to this point, to the cos axis, it's of course the same point. So if you measure it, it's what? It's equal with 1. And of course, if you bring the projection to the sine axis, it goes here, which is of course the 0 for the sine. So that means that the sine of 0 degrees is 0. And let's go and finish with the 90, because that's also very similar. So 90 degrees is of course this here. So if you go and you bring the projection of from here to the cos axis, it intersects at exactly this point here, which is 0. And if you bring the projection, of course, from this point to the sine axis, of course, it's the point itself. And just to make sure what is projection, it's the perpendicular. I mean, from this point, the projection to the cos axis is the perpendicular. That's why this angle here is a right angle. So that means that the sine of 90 degrees is 1, since if you bring the projection from this point to the sine axis, of course, it will give you, like this point here, the same point, which is 1, because as we said, always you measure this distance here. So the sine of 90 is 1. And now, let's go to find the next angle, which is the 30-degree angle. Okay, so as you see here, I have this triangle here, the ODA, okay, which is exactly this triangle here, ODA. And let's say that this angle here is 30 degrees, because I want to find what's the cosine sine of 30 degrees. So what I do, I bring the from this angle here, which of course is 90 degrees, I bring the segment which intersects the OD in the middle. So that means that this point here, the P is the median of OD. And now from this point here, I bring the parallel. So this line here, the BC, is parallel with the DA. So now if I see, again, these two triangles, the ODA and the OBC, so let's write it here, OAD and the OCB. They are what? They are similar again. Why? Because they have this here common, the O, which is 30 degrees, and then they have this equal with this. Why? Because both these are parallel to the line OA. So that means that this angle is equal with this angle, and of course they are 90 degrees, because this angle here, it's this angle, so it's 90 degrees. So that means that these two triangles, they are similar. So what does it mean? It means that since the ratio, let's see, there's a little bit here. So we have that this ratio here of OB over BD it has to be equal with the ratio of OC over CA. And of course, since this ratio here it's equal with 1, because we said that B is the middle of OD, so that means that this here it's equal with this here, so that means that OB over BD is equal with 1. So that means that OC is equal with CA. So that means that this triangle here, the OBA, it's what? It's an isosceles triangle. Why it's an isosceles? Because this point here, this line here, the OC, it's a height and also intersects at the middle of the OA. Okay, so now from that what we get that since this triangle here, the OBA, is an isosceles, so that means that if this is story, this is story too. That means that this here is 60, and of course we know that this is 62 because, you know, I mean, this triangle here is a right triangle and this was story. The triangle ODA was a right triangle and this is story, so that means that this is 60. So, excuse me, so that means that also this triangle here is isosceles. The BDA, actually this is more than isosceles, this is equilateral triangle, because, you know, if all the sides are 60, all the angles are 60, because if these two are 60, these and these are 60, this is 60, so that means that this is equilateral triangle, so that means that all the sides are equal, so that means that this is equal with this is equal with this. I mean, why I'm doing all this? Because I want to prove you that you don't actually have to remember anything when you're dealing with sine and cos. So now let's go and find the sine of 30. That's why, I mean, I'm doing all this to find the sine of 30 degrees angle. So the sine of 30, I mean, as we, by definition, if you don't know it already, the sine is the of a right triangle is the side which is across the angle over this line here, which is called the hypotenuse. So that means that for this case here, it will be the AD over OD. So we said that because this is equilateral triangle, we have that AD is equal with BD. And of course it's equal with BA. And of course BA is also equal with OB, because the BOA is also it's isosceles triangle. So OB. So what does it mean? It means that the OD, it's equal with what? It's equal with, it's equal with OB plus BD. So since all of them, they are equal, so that means that it's equal with 2. I mean, since this and this are equal, and the OD, it's this plus this, so this plus this, and since all of them they are equal, we have that it will make, let's say, 2BD or 2AD. So that means that this here it should be AD over OD, which we said that is 2AD. So this with this cancel, and we have that what we wanted, that the sine of 30 degrees is 1/2. So now that's it. You don't have to, you see, you don't have to remember anything. Now let's erase also this triangle here. So the sine, I mean, we started from the sine, doesn't matter, the sine of 30 is 1/2. Now, you want to find the cos. So we know that the cos, let's say, that this here is 30, okay? So we know that the cos is this here, so it's OA. So, but what we have that the OA, you have this here, it's a right triangle, and that means that you can apply the Pythagorean theorem, which what it says that the sum of the two perpendicular segments, so OA square plus AD square has to be equal with a hypotenuse square, but because this is a unit circle, the hypotenuse is the radius, and it's equal with 1, so it's 1 square, which is 1. So that's it. And now because we know that, that the AD, of course, is equal with OB, is equal with the sine of 30, so that's 1/2. So you just go here and you solve this equation here. So we said that AD is 1/2, so 1/2 square, so that's equal with 1. And if you continue here, you have that OA square is equal with 1, and you bring this to the right hand side of the equation, so that should be 1/4, of course, with minus. So this will be, if you put everything under the same denominator, that should be 4/4 minus 1, so that should be 3/4. And so we have that the OA square is equal with 3/4, so that means that if you take now the square root in both sides, so that means that OA is equal with square root of 3. You can break this root here, and of course the square root of 4 is 2. So that's the cos of 30 degrees. So it's square root of 3 over 2, okay? So you see how beautiful we find it. And let's find one more thing, which is relatively easy. Again, let's now say that this angle here is 45 degrees. And let's make it, the same triangle. It will not be exactly the same, but just because it will be easier for you to follow. So let's make this triangle here the OAD, but assuming that this here is 45 degrees. So let's make it here. So let's say this is 45. So again, this will be the O, this will be the A, and this will be the C. Okay, OAC. And of course, again, this here, it's the radius, the OC, so that's again 1. So let's go to find what's the cosine sine of 45 degrees. So you see this triangle here, I mean, since this here is 90, and this is 45, so that means that also this here is 45. So that means that what? It means that this is isosceles triangle, okay? So that means that OA equal with AC. And now if you apply again the Pythagorean theorem here, what you have that OA square plus AC square will give you the hypotenuse square, which is 1 square. So 1. And of course, because these two are the same, you have that, let's say, 2 times A times OA square is equal with 1. So from that you get that OA square is equal with 1 over 2. So then if you take the square root in both sides, you have that OA is equal with 1 over it's equal with the square root of 1 over 2, and because usually we don't like square roots in the denominator, we want to rationalize this, so that means that there is no square in the, there is no square root in the denominator. So what we can do, we can multiply both of numerator and denominator by square root of 2, and that will give you that, let's write here, that OA is equal with, if you multiply both numerator and denominator by square root of 2, that will give you square root of 2. And of course here you have square root of 2 times square root of 2, so you have square root of 2 squared. So this cancels with this, and that gives you that OA is equal with square root of 2 over 2. Okay, so now that I have this, I can continue and find the cosine sine of square root of 45. I mean, now the cos of 45, it's, I mean, as we said again, it's the adjacent, so it's OA over the hypotenuse, which is 1. So I have that OA is equal with square root of 2 over 2. So that means it's square root of 2 over 2 over 1. So that's equal with square root of 2 over 2. So that goes here. And of course with exactly the same logic, just saying that sine of 45 is the opposite over the hypotenuse. Again, it's the same exactly thing. So you will find that also the sine of 45 is square root of 2 over 2. And now let's continue. I mean, we only have the 16 degrees, but it's crucial. Let me erase this stuff here. So now I want to show you something which it has to do with the use of the unit circle in order to find the cosine sine of angles with respect to some other angles. So, I mean, let's say we have this angle here. Let's call it again A. So, I mean, the cos of this angle it's this here, and the sine of this angle is this here. So now let's go and draw an angle A here. This is A. So now let's find also the cos and sine of this angle here. So if you bring again the perpendicular from this point to this point, we have that this here, it's now the cos of this angle here, and this here so this here is the sine of this angle here. I mean, if you see what happens is you see that this here, which is the cos of the angle A, if you see it, this is almost the same length as this here, which is what? Which is the sine of this angle here. So, and so what, let me tell you exactly what I mean. If you see, you have that, let's say this here, which is the cos of A, which is this segment here from here to here, it's equal with this here, which is what? This is the sine of this angle here. So how much is this angle here? This angle here, since we said that this is A, this angle here is 90 minus A. So, and now if you take the this here, from here to here, which is what? This is the sine of this angle. The sine of angle A is, if you bring the projection from here to here, is this segment here. So this here, the sine of A, is equal with what? Let me tell you, it's equal with what? It's equal with, this from here to here, it's the same with this here. Which is what? What is this here? This is the cos of this angle here. Because the projection from this point to the cos axis comes here. So this small segment here is the cos of this angle here, like this angle here, which is what again is 90 minus A. We see that angles that they sum up to 90 degrees, they interchange cos and sine. So that means that since 60 and 30 they sum up to 90 degrees, so that means that they have to interchange cos and sine. So that means that the cos of 60 will be the sine of 30, so that should be 1/2, and the sine of 60 will be the cos of 30, which it will be square root of 3/2. Yeah, and of course, even without, let's say we didn't know this, the cos and sine of 90 degrees, you can get it using this here, because 0 and 90, they sum up to 90, so that means that they interchange cos and sine. So that means that this goes here and this goes here. The